I'd like to show you a system for browsing large graphs. The system is one of the many possible implementations of a general-purpose graphical fisheye browser that Manojit, Sarkar, and I developed here at DEX Systems Research Center. The prototype system that I'll be showing is implemented in Module 3 and runs on a standard DEXstation 5000. Let's now take a look at a graph representing routes between major cities in the United States. The red vertex is St. Louis. An obvious way to see more detail about a city is to zoom into the graph as in the window on the left. As we pan the zoomed image, it's obvious how we have lost the global context of the map in order to see the local detail of the St. Louis area. An alternate way to browse the graph is to use a graphical fisheye view technique. In a fisheye view, the area of interest is shown with detail, while the rest of the structure is shown with successively less detail. Notice that the entire structure remains visible. Watch now as I move the focus from St. Louis to Salt Lake City. The graph constantly changes to keep the area near the focus enlarged. Smooth, real-time animation provided the feedback necessary to keep the viewer oriented. Our prototype browser allows me to control the magnification of the area of interest and the corresponding demagnification and repositioning of all other vertices. So far, the size and position of each vertex has been purely a geometric function of its distance to the focus. However, in many graphs, vertices have different relative importance. Let's turn off distortion for a moment and use the population of each city as its level of importance. We see heavily populated cities like San Francisco and New York displayed larger than small cities like Providence and Palo Alto. Now, as I factor geometric distortion back in, the size of each vertex is a function of both its importance and also its distance from the focus. Finally, our browser allows me to choose a threshold so that unimportant vertices are not displayed. By unimportant, I mean those vertices that either have a very low preassigned importance or are far away from the focus. Recall that we're using the population of each city as its level of preassigned importance. To sum up, graphical fisheye views are a useful technique for visualizing information. They show both local detail of a particular area as well as global context of how that area fits into the entire structure. Our prototype browser gives the user interactive control over a variety of parameters that govern the display, and it has allowed us to explore some of the many interesting properties of fisheye views.